Hi, everyone. I just want to shed a little bit of light on big ideas and my opinions about it. You've had a lot of really good discussion and a lot of good points were brought up, and that's great. The Some people brought up the idea of, do you share these with your class or do you just keep them to yourself? Really, my opinion is that the work in using big ideas is in developing them. Once they're developed, they're just a way to structure your course. So, for example, in my department, we don't use Marion Small's big ideas. We don't use NCTM's big ideas. We go through the Ontario curriculum and we create our own big ideas that we think are valuable and that reflect what we value in our math education at the school. Um, so, in that working through developing the big ideas, that's where all of my teachers gain further content knowledge in order to be able to teach to these big ideas. Um, if we were just to take Marion Small's big ideas and apply them as is, then the teachers wouldn't be getting that content knowledge that they need. They would just be kind of trying to fill in the gaps. Um, the other so whether I share them with my students or not, I only share them with my students if my students and I have constructed the big ideas together. And so I do that throughout a unit. Throughout a unit of learning, we're all kind of keeping a word wall going, and on that word wall we also have our big ideas and big questions that we want to answer. So big ideas can be, and there's different ideas out there in NCTM and Van de Waal and Marion Small, as to whether they're meant for a certain class, like grade 9 academic math, or whether they're meant for math, or whether they're meant for cross curricular. And it depends again on what you and your teaching team decide is important. For us at my most recent school, we decided that we wanted a continuum of grades, so grade 9 to 12, and everybody would be using the same big ideas. So the students get to revisit the same big ideas every year. And some of the big ideas that we developed were, the main one was that relationships in math can be represented in many ways, like equations, word graphs, tables, pictures, and all of those representations should tell the same story. So what that means is that if a student was to solve an equation algebraically and they found that there was two solutions to that equation, their graph should have two x-intercepts in order for those stories to match. If a student in grade 12 calculus was to take a derivative and find 1 0 in that derivative, then their graph should only have one turning point, so that those stories match, right? So all of our representations tell us something about the relationship, but they should all end up telling the same story in the end once we extract all the information. So that's one of our big ideas. And another one of our big ideas that has to do more with geometry is, when we know some information about a mathematical object, we can usually gain other information. So, for example, in grade 10, using SOHCAHTOA, if I know the angle in one of the sides, I can find out everything else I need to know about that right angle triangle. Things like that. So that's kind of my piece on big ideas, and we'll talk again for module 12.